Talk about PowerSC. I'm Nigel Griffiths, and my claim to fame is I'm Mr. nmon. So I wrote the nmon tool, if you've come across that on AIX or Linux. But we're now going to be looking at PowerSC for the next half an hour or so. So let's break this down. Power, the power in the name gives you a bit of a hint that these are power systems we're talking about. In the power systems, our current ranges are Power 8 and Power 9. That's the actual name of the chip, the generation of the chip that comes out every 3 or 4 years. And these are the models you have that can use PowerSC. Now, on these power computers, we run multiple operating systems in virtual machines and different operating systems. So AIX is the big one for me. I've been using AIX probably every day of those 29 years, including the weekends, but don't tell the wife. Then we also got Linux, the generic name for Red Hat and SUSE. You can run other Linuxes if you want, but these are the two that we fully support. We also have IBM I. Now, I made it a little bit smaller here. This is because I don't know much about it. I have colleagues that do, but IBM has its own way of doing security. So I'm not going to talk about that. One of the tools we're going to talk about will actually help IBM I as well, but that's because it's running in something called the VIOS server. Now, if you've never come across that term, on our big machines, we run lots of copies of the operating systems in virtual machines, and we don't want to put an adapter for your network and your disk every virtual machine. You'd have to have like 400 adapters. That could end up costing you £500,000 or Euro pounds. So what we do is we put all the adapters in something called a virtual I/O server. They actually have the real physical I/O, and they talk across memory to the other virtual machines that have virtual or pretend devices they talk to. It's the virtual I/O server that does the I/O. I'm just mentioning this because the VIO server will come up quite a few times. Now, security, for me, there's a personal feeling thing here, is hard work. When I first joined IBM, I was in services on these sorts of computer, and I was doing lots of performance tuning and what we call system hardening. This was going to the operating system, doing lots of checks. I'd have a 28-page document with checkboxes, check this is the command, check this is the command, and I go through all this, so then I give the client the score, how well they're doing, and then we'll go through what they can do to harden up the computer to make them more rugged and harder for hackers to get in. Security, I think, is a little bit boring and it's limiting. When you're doing performance tuning, it's positive. You're trying to go, how many transactions per second can we do? If you check the exchanges, can we go faster? That's very exciting for me. But security is about stopping people doing things, right? It's sort of a negative, positive. Okay, you're stopping the bad guys doing horrible things, so it's good in that sense, but it's all about blocking this, blocking that, stopping this. Can we check that? Can we see what's going on? But anyway, most security is pretty boring, right? At the end of the day, who cares? Well, nobody cares until your company is hacked. I've seen quite a few clients that have the technical people can't get the business justification for buying some or focusing on the security until the first hack, and all of a sudden every manager on the planet's phoning up the techie guys saying, what are you doing? How can we fix this? What can we do to never have this again? Because they don't like being in the press or on the internet with their reports that they failed. And all of a sudden there's unlimited budget. The techies say, oh well, we'd like to buy this, buy 2 now, can you have it working by the weekend? Sort of approach to suddenly it's a very high focus thing. But of course, if it's your data that's hacked, we personally care very much, don't we? If our bank or somebody that we deal with financially, and somebody hacks in, they've got our credit card numbers and our pins or something, we have to go cancelling cards. That's a real pain in the neck. We may never want to work. It's a company again. Medical records, well, I don't have anything too bad in my medical record, but I don't want James here to know about the rash I had at Christmas and things like that. It's a bit personal. I just don't want people to know about it. I'm getting old, and if somebody hacks my pension fund provider and all the data's disappeared and my pension's gone, that's going to affect me for 10 years, 20 years. Well, it depends how long you think I'm going to last, but it's a long time. That's very, very critical to me. I really want my pension to be safe. And then these days, people are hacking in and stealing photos, aren't they? Those embarrassing photos that you don't really want people to see. You don't want your mum and dad to see some of those pictures. I don't know what you're doing. For me, for another, I don't want my children to see those pictures of what I did a long time ago, for example. So When it's my data, I'm very much more interested in people running top dog security. Now, the security people do have a problem in the numbers game, right? In my early days, a company would run 10 big Unix machines running AIX and from IBM, and they'd have lots of databases and lots of applications on there. But as we've become more and more using our computers to run the company, the numbers of computers are going up. I know a lot of customers have 1,000 copies of AIX running. If you talk to the big banks, they're into the tens of thousands of computers, all of which are running many virtual machines. So in the old days, I could check out 10 machines in a couple of days. I can't go in and check 10,000 machines for their system hardening. So we need some support, some help for the security guys working in our clients. Is in the good old days, we had 1 megabit per second networks. Now we're running at 100 gigabit per second, right? So for every one packet coming in on the network, which is always the problem area of the networking, now there's 100,000 packets arriving every second. So they're completely swamped with that. We used to run these things called firewalls in computers, but the computers just can't cope with the data rates coming in. So that function is being pushed down into the hardware. We have the network routers have dedicated hardware for doing packet inspection and working out, are you allowed to talk to that computer on that port, for example. Another problem we have, in the old days, it was me trying to fight the hackers. The hackers may have been spotty boys in the bedroom with a modem trying to hack in and guessing passwords. Now we're dealing with professional worldwide hacking teams of hundreds or thousands of people that do nothing else. Their whole job is trying to work out how to get into your computers. Now, the system admin guys are now sort of under a lot of pressure to increase the security, but the pressure, if you like, is growing every year as these professional teams try to hack their way in. So that's the S. The C is the compliance. Now, in some industries, to actually operate, they're forced to take these security standards, particularly the banks, insurance, finance, has to obey these government enforced standards. So there'll be the minimum standards that they have to reach. Most of them are actually pretty rigorous. They're great big documents. You also have to audit, so you can prove that you're obeying all these audit rules, all these security rules. They also have to have proof that they're actually doing the processes that regularly check things. We all know about password aging, for example. So you have to prove that you are aging your passwords and that you have the processes to actually manage this part of the security standard. And they also have minimum time to confess. So I think it's like 8 hours. If they have a hacker intrude on the computers, they have to confess to the industry standard people that this is what happened, and if they don't, then there's massive great fines. If they find that they do an audit on a group of computers and you're not obeying the standards, then you're into real serious problems. You're talking about tens of millions of euro, dollar, pounds in fines. And as it's one of these little jokes, but what is a bank if it hasn't got a license to operate from their government? Their answer is they are bankrupt. Now, if they failed some of the audits and it's not too serious, then they may be given, like, you've got a 2-week window to then prove that you're actually obeying all these rules, or literally they're out of business. So we want to help out the admin guys in giving them the proof that all these processes and checks are actually in place and running. Now, our operating systems have been around for many years. AIX is 5 years old these days, and it's pretty good in its security. So we do things like we have the SS, that's the secure shell. We have role-based access controls. Unix and Linux have a little problem where you have regular users and you have the super user. The super user can do anything in the computer. So if the hacker gets that privilege, then there's nothing safe on the computer. So we have these role-based access controls, which can say, look, this guy is allowed to fiddle about with the printing services. This guy's allowed to create file systems, but they're not allowed to do other things, look at other people's files and those sorts of things. AIX has these extended password attributes we can put in, or second challenge response. What's the third letter of your mother's maiden name and things like that. Checks can be added in. And we have a command called aixpert, which is quite a nice quite a nice command name, I thought. Of course, we actually have that on Linux now, but they changed the name because the Linux guys didn't want to type in aixpert. Okay. And that runs a whole bank of tests on your computer. It like has in a file full of names, and then a description of what it's doing. Then it has the rule that we're trying to obey. Then it'll have, this is the command you run to check its current status. This is the command you run to actually improve it up to the right standard. Hundreds of these rules, and aixpert will put those into one computer at a time. And of course, this is all providing that you're not running telnet or FTP in your computer room. That should be deleted on every operating system these days. And you're up to the latest version of your operating systems, because one of the things that comes out with their updates is better security. So PowerSC, I call it a toolbox. It's not an official name because there's 6 individual things in here. Now, some of them are tied together with a graphical user interface, but you can regard them as 6 different things. Each of those are optionally can be installed on the machine. And we'll go through those 6 one at a time. This makes my life very difficult because instead of talking about one thing, I'm now going to talk about 6 things. And I got one chart, or maybe 2, and some of them that gives you the broad brush, the architecture of what's going on, what it's trying to achieve, just to give you a feeling of what's going on in here. So this first one is the security compliance and automation tool. So this is actually some software you install. You can log into it. It's got a graphical user interface, and you're going to use it to get these things done. We can see here it's going to use the aixpert command on AIX, or the Power Security and Compliance Expert tool on Linux. This is a bit of a mouthful, isn't it? But we can do the 2 of those. So we have these great big set of rules, and with the compliance manager, we can actually send those out to hundreds of different machines, and then we can do audits against them to check if they're still obeying all those rules. Now, I'm not going to go through everything in here because I've sort of explained a lot of that already. We'd have to have a look at this. This is a picture of somebody actually using it in a demo. At the top left, you can see there's only 4 machines in here. I mean, this should be like 4,000 or 40,000. And we can see how many failures and how many real-time events there are. That's one of the other tools. We'll come to that one, I think, next. And this is the trusted execution events that we'll come to later on again. And we can see that, well, one of them has failed in here, so that's 25%. That's a big number. You don't want to really see that in a real computer room. Now, you group your computers. We have one group for all of them, if you want to apply a rule. But you can see this guy's got east and west, so it's a geography. This is, I think it says Power 8, so it's a particular class of the slightly older machines. We have production, well, that's the one you really want to care about, or SAP, it's a particular application. So we can have different rules that we're applying to these different groups of computers. Now, by default, the rules that IBM sends you, they've been written by people with decades of experience of securing AIX and Linux. And so the rules are very thorough and complete, and they obey the different standards that you have to comply to. But you'll find that if this particular server you're trying to operate is a web server, there'll be a rule in there that says block any web server activity. All right, so you have to take the initial set of rules, comment out that rule, and then apply it to the server that you want to be a web server, otherwise it can't do its job. So these are the sorts of things they're doing with this user interface. In here, we're going to deciding which rules to apply against which machines, and these are the standard profiles that we have here. There's some standard, high, medium, and standard level. The high level is famous because everybody says, oh, well, I'll do that. That sounds good, nice and secure. And it promptly times out the super user password because it hasn't been changed for 90 days, and they can never get back into the computer. So like a big warning here, there is such a thing as a computer that is too secure if you can't actually get into it at all. So we have the Department of Defense from America. The PCI is quite famous. That's the credit card one that everybody that's using credit cards or taking credit card details need to do this one. This NERC, I think for industries that are running like robot computers. The SOX Corbett, funny name, remember that one, but that's the standard, that's the committee in the banks that set the standard. In America, it's all about the HIPAA standard, so there's a set of there. And if you're in Europe, there's the GDPR are rules as well as a set for those. So you're going to take the one that's the nearest fit. If you're in health in England, then the HIPAA, the American standards, probably a good place to start for your particular industry. You can take all these rules and change them all if you want, or try and merge them all together to do a superset or something. But you have control of that. This is the interface that allows you to set which ones are for particular groups of machine, and then you say go and do it, and it'll then write your report about we did it on 100 servers, 10 of them failed, and these are the rules they failed on, and then you can make up your own mind whether you want to harden them up and actually apply those rules for real. Okay, here this is showing us that we have the real-time and trusted executes also into this graphical user interface. That's come about in the last year or so, so it's a good addition. Right, so how am I doing? Well, I've got a lot to get through, so let's go. Real-time monitoring. Now in this graph, I'm trying to represent the fact that the hacker gets in, right, and he starts making changes. It would be nice to see when he makes the, or her, I guess, when they come in and make a change, you want to be told immediately. You don't want to do a weekly audit, and 1 week later you say, oh, right, great, he's changed 10,000 different files in here. I've got a real mess to sort out. Maybe I'll have to rewind, go to the backups from a week ago to get rid of all these changes. You'd like to know practically instantaneously. Now, we don't say instantaneously because that's like an impossible thing in a computer, but we're talking about milliseconds later that you'll have something flashing up on your panel saying that this machine has had a strategic file, an important security file, has been modified, and who did it, and which machine it's on, and when they actually did it. So this is a very nice feature. It's an AIX feature. The idea is it's going to tell you about this very, very quickly. So we're actually going to have this thing called an RTC, a real-time compliance piece of software running, and kernel is actually monitoring these files. So it's very, very fast. We're not waiting for a process to get executed and things. The kernel will do it as it changes the file. And then it'll raise these alerts in what's called the AHA file system. That always makes me laugh. There used to be a pop group called AHA, but that's not related. And then it'll fire off alerts. It could email your DevOps team, or it can create SNMP traps. And this is sort of various monitoring services from third parties and things can get these traps coming in and escalate them to the right person to let you know you're being hacked or this was changed. It may be Fred went onto this computer and changed the password file because he was told to, because that's what he does as a job, but he forgot to tell you that that had happened. And so you would say, you can phone him up and say, why did you change this, and why didn't you alert us that you were going to make this change to this computer? Alternatively, it could be some systems administrator just trying to do some dodgy things to get his job done, and now somebody will have to go and put the security back in and check what was going on. The next one is trusted computers, and until somebody explained what this one does, I had no idea that this was really a problem. So imagine in your computer room you have lots and lots of computers and lots of virtual machines, and they're all running, let's say it's all AIX, and the hacker looks around your computer room and looks for the oldest copy of the operating system, because the oldest one will have known defects that have been fixed. But if it's an old version, the fixes haven't been applied. So these are all places that they can probe to try and get into your computer. So they're looking for the lowest place in the wall to actually breach into your computer room. So that's fairly obvious, but there is a little problem. For example, when you do an update, you may take the image on the disk and copy it and apply the update to that new copy. Then you'll boot off the new copy and you've got all the fixes. That's great. But if somebody gets in and changes the boot list, the next time you reboot it, which may be next week, next month, next year, it could actually accidentally start up the old copy. And of course, as an administrator, you just see it coming up and you will be unaware that you've actually downgraded the security on this particular copy of AIX. So this is what this system will do in here. As AIX starts off, it sends a secured message to the TNC server saying, I'm just starting up. You okay about that? And it can say, yes, go ahead if it's at the level it should be at. Or it can say, no, you are not allowed to join the network because that would be a security violation. And it will actually stop AIX starting up. And then you have to go and sort that out. You can, if you want, pull in the patch manner that says, okay, you're 2 service packs back. I know how to fix you using the NIM service, or Network Installation Manager. And so we can patch you up to the level you should be at, and then let you join the network. And we can use that as a quick way of upgrading a lot of computers. We can say Service Pack 3 is the current one Obrish on, but a new Service Pack comes out, so it's at Service Pack 5. And we can say all these computers should be at Service Pack 5. So when they get rebooted, they'll just be patched up to the right level. As somebody that's done a lot of work on production machines, this is horrifying that it would go and patch itself up. When you're doing patch on a production machine, you want to be there, you want to triple check your backups are working, you'll do the upgrade, you do some sort of regression test rather than it happening all automatically. But you might want to do those for your test and development servers to get them all up to date. And it will tell you which ones are behind, so you can actually go around rebooting those to pick up the details. Right, number 4 is Trusted Boot. This is a Rootkit attack. This is a horrible thing that your hackers can do to you. They first did this on PCs. The problem is, if you get into the boot sequence, you can, before it actually starts the operating system, you can run a virus, and the virus will grab pieces of memory for itself and put itself into memory. It will then grab the interrupt vectors, so it can actually get compute time. There's a timer interrupt 100 times a second, so it can get little bits of compute time whenever it wants. And then it starts the operating system. So the operating system then will ask the firmware, well, where is my memory? And it will be given all the memory except the memory that the virus is in. They will be knocked out by the virus. So now you have a virus that you cannot detect. You can't see it in memory. You can't see it operating. It'll actually be operating inside your interrupt vectors of interrupts with your hardware doing things. And so it's completely undetectable. So the idea here is that when it starts up, it has a sum check on all the files that it's loading into memory. And if one of those is changed, we can spot that has been changed. And then there's usually a, who did what to our computer here? Did somebody put in an upgrade that we're unaware of? In which case we haven't recomputed these sum checks. So that can get you out of that horribleness. I don't think we've actually been hit with this, but we're ready for the first one that somebody trying to do that. Right, the next one is Trusted Firewall. This is the biggest area of security. I don't want to make you sound like the network is always the problem. There's in the securities team, they're about lots of other things. For example, the security team care about the locks on the doors to the computer room, the locks on the doors to the building, and the locks on or the gates that you have to get through to actually get on site. That's all part of security. Whole loads of other things about the policies and processes that you're actually locking down your computers with. But firewalls are a big item in here. So we have a thing called a trusted firewall. When you want to talk between, we call them logical partitions, they're also known as virtual machines. When you want to talk between virtual machines that are in a hierarchy that makes it harder and harder for somebody from the outside to coming in to get into them, when they want to talk between these virtual machines, the packets have to go outside the computer via the VIOS, through the firewall, the master firewall rules in, then come back into the computer. And that takes quite a lot of overhead. So this is what we've got here. Here we got people on the internet, so they're the master firewall, and then we have these various levels that people can only talk to the web server. If that has to get some data from something, then it has to talk to the application server, and so it's on a different network. So the firewall will allow you those packets to go between those different networks. The application may need some data from you, so it'll actually go to the database server, and so it goes back outside to the firewall and says, okay, this application can talk to this database and let the packets through. And so the packets are flying back and up and down this stack all the time. When we put in the trusted firewall, we actually implement the firewall rules inside the VIO server. If you're very bright and on the ball, you'll have worked out that this isn't actually a security feature. The rules that we put into the trusted firewall are exactly the same format as the rules that go into the hardware firewall. So that's good. The firewall guys can understand them. This is actually a performance boost because we stop all those trips out to the hardware firewall and back. So it's actually a performance boost as the prime. And the last one in my last 3 minutes in here, trusted login. Okay, when the operating system is running and events are happening, you access a file that doesn't exist and all those sorts of things. So you try to look at somebody else's file, those sorts of things. They are all logged in the logs in the operating system. And when your hacker arrives in the computer room, he wants to stop the log records of what he is doing, or she, going into the logs, because it's like an audit trail of what they did. So quite often they'll copy the log somewhere else, and just before they log out of the machine, they'll put the old logs on top of the new logs, and the record of what they did will all disappear. So we need those log records. So AIX, like other operating systems, are logging to files. They can also log across the network to a log repository. These can be running all sorts of tools, looking at those logs. Maybe you've got a disk that's going flaky, and they can find that in the logs, and they can report that to your DevOps people. And they can also report problems that look like somebody's hacking. If there's a whole load of incidents happening after a particular time, it looks like a hacker's arrived at that point, and they can track that. These are also put into archives and things, and that's part of the security, the compliance that the banks and the likes have to do as well. So we've got a feature that we can actually do these logging over the network to the virtual IO server. If you're doing it over the network, well, they could have taken your AIX off the network or blocked packets going to your log repository to actually stop the log from happening. But we can do this over the memory, so they can't stop this happening to the virtual IO server. It actually makes the configuration a lot easier, because you only connect the virtual IO server for each server to the log repository, and so that makes your logs secure. When they've hacked in, the logs will be on a different computer, so we can go and find them. So that's the 6 items in there that we've covered very quickly. So let's summarize. We have the 6 components of PowerSC used by PowerSC as one item. The big winner for me is the compliance and automation management, so we can roll out these system hardening profiles with 300 to 400 rules in there, written by IBMers with years of experience, and then updated by them too. Second most important for me is the real-time compliance. That means we get the heads up, there's a hacker in the computer room, let's go and hunt him down and kill his activities immediately. Third most important for me personally would be the Trusted Firewall. This reduces the latency of your transactions as the packets fly in and out of your computer. Finally, we have the Trusted Network, the Trusted Boot, and the Trusted Logging, hitting particular security concerns. If you have those concerns, then you have excellent tools to address them. These slides were first used in a Brunch and Learn half-hour session brought to you by IBM UK. I'll put a link in the description. If you like this video, give us a thumbs up. Thanks for watching.